You know, we see it every single day, but have you ever really stopped to think about our sun? I mean, not just as a bright light in the sky, but as the actual engine that powers our entire world. Today, we're going to dive into the absolutely unbelievable power of our star, from its nuclear heart all the way to what that energy means for the future of us. And let's kick it off with a number that is it's almost impossible to wrap your head around.
Okay, so every second of every day, the sun is blasting out 3.8 times 10 to the 26th watts of energy. That's a 38 with 25 zeros after it. It's not an explosion or a burst, it's a constant, steady hum of cosmic power happening right now as we speak. It is just an unimaginable amount of energy pouring out into space constantly.
So what does a number that big actually mean for us, down here on Earth? Well, let's put it this way. If he could somehow capture all the energy the sun releases in just a single second, just one tick of the clock, we'd have enough power to run our entire global civilization, every city, every car, every factory, for over 500,000 years. That's the mind-boggling scale we're talking about. 1 second of its power is 585,000 years of our power.
So where in the world does all this incredible energy come from? It's not a fire like we'd think of it. To get the real answer, we have to journey right into the heart of the sun itself. The sun's core is, for all intents and purposes, a natural fusion reactor, and it's powered by the most immense force around, gravity. The sheer weight of the sun, all that mass, is crushing the hydrogen atoms at its center with unbelievable pressure and heat. This force is so intense that it literally squeezes them together until they fuse, and in that process, a tiny bit of their matter gets converted into a colossal amount of pure energy.
So here's the basic recipe for how the sun makes energy. It's called the proton-proton chain. You start with hydrogen nuclei, which are just single protons, and through a few steps they get smashed together. The end result is that 4 protons go in and 1 helium nucleus comes out. But here's the magic trick. That helium nucleus weighs just a tiny fraction less than the 4 protons that created it. And that missing mass? It didn't just disappear. It got converted directly into energy, all thanks to Einstein's famous equation E equals mc squared.
But there's a problem. If you do the math using classical physics, the sun's core isn't actually hot enough for this to happen. The protons are like 2 magnets repelling each other, and they shouldn't have enough speed to slam together. So how does it work? Well, this is where things get really weird. The answer is something called quantum tunneling. It's like a cheat code in the laws of physics. At the quantum level, a proton has a tiny, tiny chance to just pop through that repulsive barrier instead of having to go over it. Without this quantum weirdness, our sun just wouldn't shine. Simple as that. And what's so amazing is how incredibly inefficient this whole process is on a particle-by-particle basis. The chance of any single proton actually tunneling and fusing is ridiculously low. In fact, a proton could just be floating around in the core for billions of years before its number is called. This incredibly slow, gentle burn is exactly why our sun is so stable and lasts for so long, about 10 billion years in total, which gave life here on Earth all the time it needed to get started.
So you'd think the sun's core is this raging, super efficient furnace, right? Well, get ready for this. On a per kilogram basis, your own body generates thousands of times more energy than a kilogram of the sun's core does. The sun's unbelievable power doesn't come from being efficient. It comes from its almost unimaginable size. It's a very, very slow metabolism, but there's just so much of it that the total energy output is absolutely astronomical.
Okay, so we get the engine now. We know where the power comes from. But how does that cosmic energy travel 93 million miles through space to reach us? And how does it become the electricity that we actually use in our daily lives?
Now, of all that incredible energy the sun is blasting out into space, just look at this chart. Look at how much actually hits our planet. Because we're such a small target so far away, we only catch that tiny, minuscule fraction you see there. Almost all of it, 99.9999%, just radiates out into the cold, empty void of space. It really puts our little home into perspective, doesn't it?
But, and this is the amazing part, that little sliver, that seemingly insignificant crumb of energy, is still a mind-boggling amount of power from our point of view. The solar energy that reaches Earth is more than 10,000 times greater than all the energy our entire civilization uses in a whole year. The resource isn't just abundant. For all practical purposes, it's infinite. This table really just hammers the point home. Let's look at the numbers. At the very top, the sun's total output every second, a massive number. The next line down is what hits the Earth in an entire year. Still huge, but then look at the third line, what all of humanity uses in a year. It's thousands of times smaller. And then, at the bottom, the Tsar Bomba, the most powerful nuclear weapon we've ever created. It's barely even a blip in comparison. This is the sheer scale of the energy source hanging right above our heads.
And the good news is we are finally starting to tap into this source in a really serious way. Just look at the growth in the last decade or so. Solar's piece of the global electricity pie has more than doubled. You can see a clear and rapid acceleration in how we're learning to harness the power of our star.
So what's driving this huge shift? What's the secret? It really comes down to one thing: economics. It's just cheaper. We've hit this incredible tipping point where, in most parts of the world, if you want to build a new power plant, building a huge solar farm is the cheapest option you have. That simple economic fact is fundamentally changing the energy game. But our story with the sun isn't one that lasts forever. Like all stars, it has a life cycle. It has a beginning, a middle, and an end. So let's fast forward billions of years into the future and see what the ultimate fate of our solar system actually is.
So right now, the sun is in its stable middle age. But it isn't completely static. As it keeps burning hydrogen in its core, that helium ash builds up. This makes the core contract and get hotter, which in turn makes the fusion reactions run even faster. The result? The sun is slowly but surely getting brighter over millions of years. And this gradual brightening has some pretty serious long-term consequences for our planet, as you can see on this timeline. In about 1 billion years, the extra heat will literally cause our oceans to boil away, sterilizing the planet. Much later, about 5 billion years from now, the sun will run out of hydrogen in its core and swell up into a massive red giant. And yeah, it'll eventually expand so much that it'll almost certainly swallow the Earth whole. It's a definite, unchangeable ending written in the star.
Okay, so let's bring it back to today. We have this practically limitless river of energy flowing past us right now, but we also know that in the very distant future, there's an end date. So where does that leave humanity? How should we think about our own energy journey on this cosmic scale?
There's actually a really fascinating way to think about this called the Kardashev scale. It basically ranks civilizations based on how much energy they can use. A Type 1 civilization has mastered all the energy that naturally falls on its home planet. You could say that by building out a global solar grid, we're taking our very first baby steps towards that. But a Type 2 civilization? That's a whole other level. They harness the entire energy output of their star, maybe with something crazy like a Dyson sphere.
And that really leaves us with the big final question. What is our ultimate energy destiny? Is it to become a mature Type 1 civilization, living sustainably on the sunlight that graces our world? Or will our far-off descendants one day reach for something more, to tap into the full, incomprehensible power of our star? When you think about it, our journey with the sun has really only just begun.